In this week's traffic update, we're taking a look at improvements to a lot of things, including the fact that now cars actually wait for the other ones to pass through before they actually start moving, and they, of course, let the cars behind them know, hey, it's time to go. Let's go ahead and move forward, and then they will, of course, stop automatically until it goes to the next one, and it continues on as we'd want. Now, there's other improvements, of course, and of course, there are other things that are just need still some ironing out that doesn't work perfectly yet, and we'll continue making improvements until we get to the result we want. The first thing is, here we are back in our original project. Right now, this is green, this is red. So that means after this is done, this should turn red, but it doesn't. This one turns red. So this is technically still green right now. So we have a few bug fixes also to make, some improvements. Let's start with fixing the actual intersections, telling things in the wrong order. For that, I'll just open the traffic intersection blueprint, which is this guy right here. We have a drive and a stop section. The problem is the stopping is where I'm incrementing the traffic light. I should be incrementing that on the go because I want to first turn the one that was green red and the next one should go. I got it backwards. Easy mistake and thankfully easy fix. So what we need to do is basically after this plus, we need to detach this and we can take all of this and this is going to go up above. And then same thing here. All of this from the loop forward needs to go down below. So all of this goes down here and we'll just go ahead and plug it in. And all of this goes here. Now, this does mean that we've effectively have swapped the stopping and the driving. So that means we just need to update the comments to now have this one say drive and we can make it green and this one can be the stop. So there we go. This is actually a little more accurate to what is actually going on. The other thing I want to do is just give a slight delay to the drive, right? When we run the red light to stop the cars, I want to give it a little bit of time so they can finish going through the intersection before the next one turns green, which is also realistic. There's a period of time when you don't have any green lights typically, at least the ones that I've observed. For that, all we need to do is just add a little bit of a delay. Before we drive, I'll just say, let's delay it by 2 seconds. So first we go ahead and wait 2 seconds and then we continue. And that's fine because the timer is a longer duration. In our case, it is 6 seconds. So that means effectively the green light is now 4 seconds because we are removing 2 seconds right here. Now 4 seconds I think is too low, so we'll increase this to 7, which effectively makes this drive green light 5 seconds long. So just remember the traffic light duration minus the delay is actually going to be the duration of your time. What we can do though, to make it easier, is we could say the light duration is 5 seconds, and then up here, we can go ahead and say traffic light duration plus the 2 seconds we have for the wait. You can, of course, expose this as a variable, so you can plug it in here and here in case you want to change that. For now, though, I think this is just fine. So we take a look down. We have a red one. There's a green one. So this one should turn red in a moment. And there we go. It turned red. And the next one, there we go, turned green. We have issues here, but we're going to be fixing all of those issues. The main thing, intersection 1, good, better. The next thing I want to change is when we're off of a spline. When we're off a spline, I don't want to continuously be looking for the next spline. Instead, I'm going to do one trace very far down and find the spline and then angle the car so it aligns with that spline point basically. So it almost guarantees that it will actually snap to it a little bit better. And then we don't have to keep checking constantly, which is good. We have this trace for new path function here, and I'm going to convert this to an event. For that, we just right click and select convert function to event. The reason I'm going to do this is because I'm going to add a delay. So that way, when we find something, it can go ahead and say, okay, got it. Now let's wait for us to get closer and then activate the spline. So let's go ahead and modify this. This is fine, except now we don't want to do it based on the speed. We just want to go a certain distance. So instead of this current speed and all of this, we're going to remove all that. We're going to use the forward vector and we're going to multiply it by a distance. So I'm going to right click on this pin and remove it. And I'm going to right click on this one and convert it to a float. And I'm going to say, hey, just check like 10,000 units ahead. This number is very big just for testing. Most likely, you're not going to have to do this at 10,000 distances, but this is just so I can put them very far away without having to do a road in between. So we're checking ahead from our location forward 10,000 units. We're still looking for the traffic road. I want to increase the radius we're checking though. Let's set it to be something like 200. That should be plenty. So that way we can go a little bit left and right. You can of course increase this number if you're okay with it potentially turning more at the end there. but 200 seems to work pretty well. And now here, assuming we hit something, which is a problem if we haven't, so if we didn't hit something, I want to know. We'll do a print string, and we'll make this print string red. Keep it around for like 5 seconds so we notice it. And for the string itself, I'll just say could not find new spline. We should pretty much always be able to find a new spline. If we don't, we have a problem. So assuming that we found one, let's go ahead and make some room down here. I'll digitize this for now just to get out of the way. I want to first have our actor face towards this hit actor, or rather the hit component. So we found a spline, we found the road, the path. Let's angle the car so it's going to be a bit better and closer onto that point. So for that, I need to know where things are. From the hit component, I can do get world location, which will tell us the location of this thing that we've hit, which in our case is this collision box of this path. So this is the start of the path. And I want to know where we need to face. So I'm also going to get actor location, which is our current location. And I can find how I need to rotate to face it. So I'm going to get actor location. I'll just drag out and do find look at rotation. And the destination is this world location of the hit component. So now we have our rotation. So from true, I can do set actor rotation and target is self. We're rotating ourselves to this rotation. So now we're going to be automatically facing the component that we hit, which will help the fact that we don't need to now line it up perfectly to be able to get onto this new path. But then, okay, we might not be close enough yet. So let's do a check to make sure we're close enough. We need to see what the distance between us and this location is. So I'll just drag out a 1 and use a distance vector. And then I'll plug this like so. So we're checking again between the hit component and the actor, what is the distance? And this one will be based off of the current speed. So as long as the distance here is less or equal to the current speed multiplied by the frame rate, which we can use the get frame rate function to plug that in. So as long as within our speed, we will be able to connect there, we should be fine. Now, of course, you can add a multiplier here. Like, for example, if you're okay with just a slight, unnatural, like pop, right? Because at the end, right, it'll check if it's within that distance. It will help to fix some issues, but most likely you're fine with leaving it as is. I'll go ahead and just remove the pin entirely. I have seen that on occasion, it doesn't get the spline still. That is something for me to look into, but I don't want this to be the way to fix it because I don't like that little pop. So I might make some tweaks later on to improve things, but just know it has happened. I just haven't figured out why, because it seems like it gets all the information just fine, but it's rare. It's not often, but even if it was 1%, I still would want to fix it. Okay, well, now that we know that the distance here is within the speed that we'd normally go, then we can go ahead and say, okay, we're good now. Let's go ahead and set this up. Now, what is this one doing? Well, it's doing a lot of stuff, which is pretty much all the stuff we're right now doing. So we don't need to do all of this. We don't need to do it again. So I'll just take this component by class, the random, the setting of the spline, because we've effectively done the rest here. It's just we have a slightly different setup here now. But really, we actually just grab this delay as well and this. Let's go ahead and copy all of this. Instead of this, we'll just paste this in and plug this through into the connection here. So let's go ahead and reorganize this. And this get component by class is, of course, off of this hit actor. We'll just plug that all the way through. So now we are checking the distance as we were before, but we're now also doing a find look at. So we're rotating to where we need to do it, and we're checking, hey, is it close enough? And if it is, set the spline. Now, we also need to specify a few other things, like don't do this multiple times. So on this trace for new path, I'm going to just drag out and use a do once. So I want this entire thing to only happen once and only try again if it made it all the way to the end, and then go ahead and reset it. So that way you can go ahead and find a new path, because at that point we got a new path. It will reset at some point. Let's go ahead and allow it to happen again. Again, if it failed here, we have other problems. So I just want to know so that way we can go ahead and fix it down the line. I'll go ahead and just take all of this and comment it. And I'll say, do one trace for a new path. Perfect. Now, when we get started right now, since we're not starting on a spline, we need to let them know, hey, go ahead and find the first path. Once we have a kind of a spawning system where it just spawns them on the splines, we'll obviously assign them. For now, though, they're not pre-assigned. So let's go ahead and adjust for that. On this drive, I want to take a look if we have a valid current follow spline. So let's go ahead and just drag it out, then right click on it and convert to validated get. And I want to know if it's valid, because if it is not valid, then I want to do this trace for new path because we just told it to drive, but we doesn't know where to drive to. So from this is not valid, I'll just search new path and I'll get my trace for new path here. But only do this if it's not valid. So this is great, but we still have the old system set up. Over here in the drive forward function, we're doing the trace for new path basically on a timer. Now we no longer need to do that. So I'll go ahead and just remove it here and we'll only leave the trace for car. Again, we'll optimize this later on. Once we have things working, it's easier for me at least to optimize later and just do like the dirty but working system first. Let's go ahead and take a look. So the cars should still work, the ones ahead, the same as before. Here it goes, it turned green, and yep, this one turned right, this one went straight, and then this one, when it turns green here, it should still go and follow the spline. And what we can do is change this debug on this trace for new path for a duration, just so we can visualize it. And if I go ahead again and hit simulate, you can see each one of them has found it, and now it will try again only once when it turns green. Again, issues here, but we're fixing that. So now it only does it right at the beginning once, and then it continues on. And then once again, when it turns green for whichever lane, it will do it once, and then you see again, went right, went straight, and it will continue doing that. Again, same thing here. Now this one will find this path and continue on. So we're no longer tracing constantly when we're off of a spline, which is good. That's a nice improvement. I'll go ahead and turn off this for duration though. Another issue that I actually found was on this get future position and rotation along spline. In here, we are using this get distance along spline at location. And this has given some headaches because it seems when the spline is kind of curved, it has a hard time figuring out exactly where the car is. So instead of always checking, we can just store it as a simple float and update that float and read it as we need. So let's go ahead and add a new variable. I'll call this current distance along spline. We're going to change the type here to be a float. And now I can go ahead and grab it and use that instead of this get distance along spline at location, because the distance is going to be right here, which means we can go ahead and get rid of this. And when we get this information, this right here, we need to store it back onto it. So we know the new distance. So right after this start here, we will set the current distance along spline with this calculated one that we just did from this addition of this information. There we go. I've cleaned it up so it'll be a little bit easier to see. Current distance along spline, we're adding the distance we're traveling, and we're setting that to the new distance. That also means that we need to keep track of this value in other places. For example, on side of this trace, well, when we're actually setting this new spline, I want to make sure that, hey, we're starting at the beginning, so go ahead and reset this current distance along spline to 0 when we set this path. So let's go ahead and set that up. And I'll also go ahead and just put it over here into the set current spline component. We're still using it technically. We'll eventually get rid of the system, but for now we're still using it. So I want to put the current distance along spline here again to 0 when we assign a new one. So now let's take a look. Are things going to continue working? A little bit of a teleporting there. Now, why are we just teleporting right to the end here? The reason that's happening is because we have some things to fix up over here. So if I was to detach this trace for intersection, trace for car, and write all of this, and then went ahead and simulated, you will see that, okay, they snapped to that road, but obviously the rest of this is broken, but you can see that at least the moving of it is working. So let's fix the tracing for the car ahead. First thing I'm going to do is just go ahead and attach the trace for car by itself right after this set actor location and rotation, because I'm going to do the trace for intersection later based on a conditional. So again, with it just plugged in, you'll see that, oh, yep, teleports right to the front. So you can see that's where the problem is. So the first thing we're going to change is this get future position and rotation along spline. We're going to use a slightly different function here. It's not going to be based off our speed. It's just going to be a certain distance ahead. And the distance ahead is going to be our deceleration distance. Last time we set up a max deceleration distance, but we are not ever using that distance. So this is where we start using it. So in here, what we're going to need is just get this location at distance along spline, the follow spline, and the current distance along spline. So let's copy all of this, come on here, and just paste it in. So now we have the spline that we can plug into the target. The distance is going to be the current distance along spline plus the max deceleration distance, which is here under controls that we have, max deceleration distance. We can plug that in, and that is the distance that we want to check at. So go ahead and use this as the end. And the start here, instead of all of that, is just going to be the current actor location. We're going to right click, get actor location, and that's going to be the start. So check from us forward this distance along the spline for a car. Now, along curves, it does mean that it'll be kind of like slightly bent. For the time being, I think that still works fine, because if there's a car even at an angle that will cause issues for you, Theoretically, you'd probably want to slow down for it. It's not perfect. We might make improvements to it later, but for now, it does the job. So, okay, so we're doing a different trace now, but we're still checking that we're hitting the vehicle, and then we're checking that we're hit the proper vehicle, we're getting the speed, we're checking if its speed is lower than ours, then we're setting the deceleration goal to be the speed, but we're now no longer setting the deceleration distance because we just removed this part. Now this is now, instead of u, is going to be using the distance from the hit result. So that is now going to go into this minus 200 and max 0. Let's go ahead and just adjust the positioning of this for organization. And from a little bit more testing, I found that minus 300 did a much better job. Again, this is all depending on the size of the cars. We'll probably adjust this automatically later. For now, I'll just hard code it to be 300. So that sets the current deceleration distance. Then, like before, we're clearing the acceleration timer and stopping the car. Now, for the false here, if there is not a car ahead of us, we want to do a few more checks. Well, first of all, I want to reset our max speed. So I'm going to set max speed after we fail to find a car ahead of us, and we want to set it with the original max speed. But we haven't stored that. We don't know what the original max speed is anymore. So what we can do is just store it as a variable at the very beginning when the car gets spawned. So over on the event graph, we'll go here to event begin play, where we're setting the current deceleration distance to the max deceleration distance. We can add a new variable, and we'll call it original max speed. And we can go ahead and set this, as you might have guessed it, with the max speed that we've piped in. So that way, even when we change the max speed, we can always know what is the original max speed of this car. Now let's move this into the speed category here. And we put distance along spline into its own category. Let's put it under spline. Now we're actually going to need to reset the max speed a few times. So let's go ahead and just add a new function for it. I'll call it reset max speed. And of course, all it's going to do is take the original max speed and set the regular max speed. So we'll go ahead and just set it just like that on reset max speed. The reason for that is because we need to reset the max speed when we do drive. I want to make sure that when you start driving, it remembers what was the max speed, because maybe it stopped at an intersection and there's no cars ahead. There's no reason for it to be driving slower now. So start by just resetting it the max speed back. So I'll just plug that into the drive. So we'll do the reset max speed first, then I'll do the drive and the checking for the new path. Now, when you have this in, make sure to change this drive function now to after it, because otherwise the original max speed is 0. And if we have the drive first, that means when we do a reset, we're going to set it to be 0, which means they won't go. So very important to have this in the right order here. That also means back here, if we don't find something, we can now, instead of setting this here, we can just say reset max speed, and that can just go ahead and get plugged all the way through. Now there's a scenario where it succeeds on finding a car ahead, but the car's ahead speed is not actually slower than ours, because maybe it is now accelerating and accelerating now to go faster, and we're just starting to catch up. So we need to set our new max speed based off of that. Now we want to make sure that's never going to be above the original, but as long as it's increasing, we can increase ours as well. So from this false, we'll go ahead and set this max speed, and then I'm going to use a min float. So what this allows us to do is to use the current speed of the car ahead of us, as well as the original max speed. And whichever one is smaller will become the new max speed. So in case that car is slower, we want to catch up to it. This way, when we set this max speed, if the car ahead of us is accelerating, we will never start and accelerating way too much past our limits. And after that, it's going to go to this branch to start acceleration as it was doing before. Now, because we have changed this and changed some stuff here, it's actually now much closer to this system. So we might as well just combine the two at this point. To do that, it's kind of like what I was explaining before, which is just taking the current follow spline. I'll just go convert it to a pure get, and we'll check if it is valid. And we'll want to use the function Boolean output, because we're just going to use the start and the end to change where we start and end. Now, originally, we were doing it, again, based off speed. We're not going to do it based off speed. It's still going to do max deceleration distance. But the difference is we're not checking along a spline. So I can go ahead and just take all of this and then grab this follow spline and then drag from end and do a select, or just do a regular select here. Plug this Boolean through. So when it is valid, go ahead and use get location at distance along spline true. So great, just use that. When it is not true, we need to use the forward vector. So go ahead and grab the forward vector, just come up here, and here we need to multiply it by this max deceleration distance as we were doing before. So we'll go to plug that in, and then we just add it to the current location. So I'll just reorganize this a little bit, get the actor location, and plug that in. So that is the new false. So we're checking ahead the distance of this max deceleration distance when we're not on a spline. And when we are on a spline, we're checking it along the spline. That also means that this check here is no longer needed. We can just go ahead and do trace for car this way, kind of clean this up a little, and remove this entire bottom section. And well, the comet no longer makes sense anymore. So we'll go ahead and remove this and just clean this up again a little bit. Now, technically speaking, this is actually going to cause you problems. But I wanted to show what happens when you do this, because it's a very common thing that even I set up constantly still and I forget about. If you come here and just try to simulate, you'll see nothing moves. And when I stop, you'll see a lot of axis none trying to read property current follow spline. Now, logically, you would think, well, hold on, we're checking if it's valid. That's the whole point. Well, here's the thing. A select node will load every path that it has connected here. It will load false and true no matter what you have here. So that means that it is now trying to do current follow spline get location at distance along spline, even when it returns false. Even though it's not supposed to go in true, it still does it. So this is a simple adjustment here. All we need to do is just grab the current follow spline and go back to using a validated get, and we'll just do a little sequence here. So first, check if it is valid. If it is valid, then we'll store a local variable of this end trace location. So let's add a local variable here. I'll call it end trace location. I'll make it a vector type. And so when it is valid, go ahead and set it to be this location at distance along spline. So we'll just go ahead and just move this up here and plug this in. Now, when it is not valid, we'll say come here and use this one, which is the forward vector one. Go ahead and plug that in. So instead of using the select node now, we're now using this end trace location here. So we can just go ahead and move these over and then first find which one it is, and then go ahead and do the trace. So just like so. Now, before we can actually go ahead and test it all together, we do need to also improve and fix up the trace for intersection setup. So here on the drive forward, right, we have the trace for intersections. If we go open it up, you'll see here we are setting the current deceleration distance, but we're never setting the deceleration goal here. The goal being here is our goal speed. So we're trying to stop. It says stop at intersection. So we want to change this to say, hey, the deceleration goal, go ahead and set that to 0. And then try to stop the car. But also, instead of checking specifically ahead of us, there's no reason to check ahead on the spline. We know where the actual end of the spline is and the potential intersection is. It's at the end. So instead of checking just ahead of us, let's just check at the end. So we're already getting the location at the last spline point. So we just need to get the rotation now at the last spline point. So get rotation at spline point. Again, same point index, and make sure that this is set to world. And now let's go ahead and kind of modify this here. I'll go ahead and just erase all of this, but luckily I did not delete the get forward vector because we need that from this rotation. So we have the last point and the direction the last point faces. So we can take the forward vector of that last point and then multiply it by distance. So I'll just right click, convert to a float, and we can give it something like 1,000 or 2,000. This is just a matter of how far away are your intersection splines going to be from the regular ones. If they're further away, increase this value. If they're going to be right next to each other, then 1,000 will be just fine. In fact, for me, 1,000 is just fine, so I'll leave it at 1,000. But go ahead and basically project it forward and then add it to the location of the original last point of the spline. That is going to be the end. And of course, the actual last point will be the start. So we'll do something like this. So no longer are we checking every single part along the spline, it's just at the very end. That does mean that the way we're getting this current deceleration distance does need to change. Well, we can just use this get location at spline point and check its location relative to our own. So drag out of here, do a distance vector, and we're comparing it with our location, so get actor location. Now, I don't want it to be right at the end. I'm going to do a simple subtract. I'm going to say, hey, when you're 100 from the end, let's first check if this is less than the current deceleration distance. Because if it's not less than, then I don't even need to update this current deceleration distance. I don't need to do any of this. So let's add a branch here and say, okay, go ahead and plug this in from true if this is true. Let's move this all the way forward. And assuming that it is true, then go ahead and plug it in to the current deceleration distance. And this -100 is the same one we had here. I just moved it over, so just like so. But it's possible that at this point in time, we've set the current deceleration distance, but it's still further than the maximum deceleration distance that we want. So basically, let's say your car stops within 1,000 units, but you're 2,000 units away right now. We don't actually want to stop the car yet, because there's no reason for the car to start slowing down way in advance. You've said that, hey, the car stops within 1,000 units, let's wait for that to happen. So using the same number, we can check if it is less or equal to the max deceleration distance, and then only do the stop car and set current spline path if that is true. So plug this all the way through, and then this goes into this branch. So a little bit of tidying up later. You can see here, we're checking the distance based off of the current deceleration distance, and then adjusting it if we need to, and as well as the max here. And then if we need to brake, then we need to brake. This doesn't mean we can start plugging in this. But the main thing is, I don't want to do this trace for intersection here on this drive forward unless we're even close to the end. Why even do the trace at all if we're nowhere near the end? So after the trace for car, which we're doing regardless, I want to do a check. And only if the check returns true will we do this trace for intersection. Now at this point, what we want to know is the distance of the spline compared to the distance we are along that spline. So that way, when we're close to the end, we can say, okay, time to start checking for the intersections. Because before that, there's no reason to even do any of that. Let's go ahead and grab the current follow spline and do a get distance along spline at spline point. The reason we're going to do spline points because it's very easy to get. As before, we get the number of spline points from the current follow spline. And because this starts at 1 and not 0 like an array, we need to go ahead and subtract 1 here. So that is the distance. Now, if we take this distance and we subtract the current distance we're at, so we'll grab the current distance along spline and subtract it, we can now check if this is less or equal to the max deceleration distance. Because if we're not there yet, don't even bother checking, honestly. Just go ahead and ignore it. But if we're at a place where we should be braking, well, let's go ahead and check if we should be. And if we're near here, that means we're near the end of the spline, which means that we should probably be checking if we need to clear it entirely. Now, I've been using this equal within a range here. I want to say that you can absolutely, again, use a distance vector here between the two locations instead, again, and make sure that it is less or equal to a certain range. Let's put it back to 75, I believe it was, and see if that's true, right? There's no real difference from what I can tell. Only reason I'm changing it right now to this distance as I'm showing it is just to keep it consistent with all the other ones that I've been using that uses distance. Visually, it is much easier for me to be like, oh, we're checking the distance and there's the lesser greater versus the other one, which is just visually not as clear just at first glance. At that point, I think it's a personal preference. I don't think that under the hood, there's really any difference. But if there is, and you know about it, let me know. So once we do this trace for intersections, we'll go ahead and do this check, and then we're pretty much good to go to clear the false spline if this is true. The only thing is, when we do this and we've cleared it, well, we need to know what the next one is. So after that, we just do a trace for new path, because that is the one-time trace that we're doing right here that we've set up just earlier in this tutorial. So let's go ahead and take a look. Well, the cars are going to see there's a stop there. Oh, that stopped. Oh, why? Wow, they're stopping so far away. That's way too far. And you might think that the problem is the trace for intersection, this right here, -100. The fact is, actually, it's not. The problem that we're having is actually on the deceleration. We're using the max speed for this deceleration when we're not going the max speed. We're going the current speed. So we'll just swap this max speed for the current speed, just like so. And while we're here, I want to do a check. I want a fail-proof plan that if we're basically need to stop now, it stops. So I'm going to take the current deceleration distance, and I'm going to check if that is less or equal to 0. Basically, are we supposed to stop? Like now? And if it is true, we're going to just throw it into a Boolean here. Then it will do something else. But if it's not, then obviously we still do the original stuff. So if it is true, we need to stop now. We can bypass a lot of this. We just need to go all the way past it to this set current speed off of this deceleration goal. Because basically, at this point, we need to be already at our goal. It's too late. The slowdown or whatever it was was either not enough or whatever it is. Let's go ahead and just set this up as a precaution. So now that's using the current speed for the deceleration. Let's take a look. There we go. That slowed down. Oh, look at that. Look, they're slowing down. That looked really nice. It seems like the distance here is a little bit too far. So what we probably need to do is make sure that the distance here of these points is a little bit closer here. So let's go ahead and just move these a bit closer. Because remember, this is doing a trace. The alternative, by the way, is to move this box also forward a bit. So you have a bit of options of how to tackle this as well. To make it easy though, I think just moving these a bit closer is a simple solution. So let's try with this. I'll go ahead and tell it to go one more time. And let's take a look. That has slowed down nicely. Oh, look at that. The cars are slowing down quite nicely. And then there they go. So that's working really well. Now they're not telling the cars behind them to go just yet. Well, you can see, yeah, that one just rotated to face it and it's continuing on. So the last thing is to tell the cars behind us to go. And the way we're going to do that basically is when we are told to drive, we're going to trace behind us and tell us, hey, car behind us, you can also go. But we're not going to do that immediately when driving. We're going to give it a little bit of a delay of a random range. So that way it feels like instead of like a machine perfectly moving together, realistically, people have different reaction times. One car starts to go, the person behind like, oh, okay, now I need to start accelerating, right? And then the person behind like, oh, now that person in front of us is accelerating, now we need to go. To simulate more realistic movement of cars, basically. So back in the event graph, after we do this set new path, we're going to do something else. So I'm going to do a custom event here. So we keep things a little bit organized and separated. I'll call it something like make car behind drive. I'm not good with a good name here. If you have a better suggestion, please let me know in the comments. But basically, whether or not it is valid or not valid here, we still need to do make car behind drive, just like so. So how does it tell it? And where does it tell it? The way I find easiest to do this is to go into the viewport and add ourselves a new component. I'm just going to add a simple scene component. And then I'm just going to move it behind the car. And I'll move it specifically minus 500. Basically, one of the cars should be here if we're telling it to move, which includes this front section. So if they're here, then we let them know. And I'll change the name of the scene component to be behind car location. Because now we can go ahead and grab this behind car location and get a get world location. So we know where it is in the world. Otherwise, we can also do a get current actor, do the forward vector, get it behind us, move it behind us, and do that way as well. This is just another way of doing it. And I want to show you guys different methods for different things. You can use them interchangeably, more or less, at least for this setup. But I like showing different ways of doing things. So now that we have that location, all we're going to do is a simple line trace for objects. So the location is going to be this location, and we're going to add just something like 200 up into the air. That's going to be the start of it. And I'm just going to subtract 200 to make it go a little bit lower as well. It's not super needed, but this way it has a little bit of a range for this trace. Now the object types, of course, we need to do vehicles. We'll do make array, and we'll make sure to specify vehicle. And then if it goes ahead and hits something, then we obviously need to tell it to drive. But if it hits something, let's go ahead and break the information of this hit. So we have all the information. And I want to know, did we hit a car of this car base type? So cast to BP car base. And if that is true, then we work with it. Now, the first thing I want to do, though, is not tell it to drive, although we can just drag out and select drive. I want to do a delay. So first, do a delay and give it a range. So for that, we'll do a random float in range. Wait somewhere between a second and 1.5 seconds. And then go ahead, drive. This is the rough time where I found that it looks pretty nice and doesn't have any issues, so we'll go with this. So basically, when the car is told to drive, then it goes ahead and says, hey, is there a stopped car basically behind us? If there is, tell it to go, but after a certain delay. Now, this location is already set in stone. It has done the trace. So even though the car has moved forward, where it's going to be notifying the car in the back hasn't changed. So now if we take a look and we just have these guys go forward, we will see that first, these guys will all stop here. And then here they go. And then there's these guys go. And you can see there's a little bit of a delay between the two. And just like that, we have a little bit of a delay and they're off. So I've gone ahead and put in a bunch more cars, and some of these are different speeds. For example, this is 1,000. This one's 2,000 at speed. So we have a little bit of variation here. So let's see what happens when we go ahead and simulate. So here we go. Car stopped. There was a green light there, so they've continued on. These guys stopped. Fantastic. And now these guys are going. So good. And they're turning. This one should stop. There we go. Went ahead and stopped, and now these guys are going. You can see there's a little bit of a delay as they continue on. Red light, it stops, and there we go. Now these guys are going. So it seems like it's working pretty well, and there's a little bit of a delay, of course, before the next car goes. This one seems to be going quite slowly. So again, there's some issues still. It is not a perfect system, and this guy somehow got stuck all the way back there. If we run it one more time, let's just see what happens. And if I make a note of what's happening in the top left, I don't see any, like, did not find spline prints. Oh, there's some, but then those are the two cars that got off the track, and it's obviously nothing there. But yeah, we got an issue right there. So it's not perfect, clearly. But I think the main thing is here is because I've made these a little bit too close now. Because now the way it angles, it just makes it actually have other issues. So is the system, flawless? No. But it has significantly improved since last time, and I will continue to try to improve it even more as we continue on. So now we can take a look here. Now that seems a little bit better. These guys are all going straight, but I think that's just RNG on that one. Because if I had to run one more time, I imagine some of those cars would turn right. Let's just take a look. Here we go. There we go. One turned right, one went straight. And these guys are going very slowly. They are moving. I wonder what's causing that. Of course, leave it to the very end where I'm showing off the tutorial for me to experience new bugs. That's just the life of a dev, isn't it? Good old Murphy is always going to come in and say, hey, I know everything was working fine and beautiful, but now that you need to show it off, I'll show you a new bug. That's okay. We'll get it fixed, but things are at least improving, and that's the main thing. If you want to play around with this project for yourself, it'll of course be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything else is always in the description down below. And if you're looking for something else to watch, I recommend this video, or rather, YouTube definitely recommends it.